Hello and welcome to this edition of Learning R for biostatistical data analysis. In this particular module, we are going to learn how to use graphics in R. We shall start with an overview of the different graphics engines in R. As you know, R itself comes with its own installation of the graphics device and graphics engines. We shall learn how to use those inbuilt graphics engines in R. We're also going to learn, but we are not going to learn in much greater details or depth, the other kinds of graphics engines, that is using the grid graphics system in R. However, remember the grid graphics systems are very popular. For example, we have got R's own inbuilt external packages known as lattice package that you can use. And lately there has been much interest amongst graphic designers as well as data analysts using a package called ggplot2. So we're going to learn these different things, and I hope that at the end of this module you will be confidently using R for running your own data analysis and producing good graphics. Thank you, and so let's get started.
We're going to learn 4 essential topics today. First of all, we're going to learn some of the concepts of graphing in R. We're going to learn what are the different types of graphing systems and graphs that are used in data analysis when you use R. We're going to learn how to create graphs in R in various systems, and how do we export graphs from R into other systems. For example, how do we export graphs from R into other kinds of file formats, and we can use them. In addition to these bank of slides, there is also another PDF document that you should be following through, and there are RNW files, which are, for example, woven files, which you should be able to use to work along and follow along this lecture. For this, you will need a working installation of R in your system, and you can open the RNW file in that particular in the R source file, and you can work from there, or you can copy and paste codes from the PDF file, and you can play along and follow along as we go along. So in the next few slides, I'm going to talk and discuss about the different high-level functions which can produce complete plots within R, issues such as low-level functions using which you can add outputs to the high-level functions in R plots, and some of the inbuilt graphics systems, which is quite powerful actually, and you can use a lot of things using the inbuilt graphics systems. And then we're going to introduce 2 grid-based graphing systems within R, and these 2 grid-based graphing systems within R are known as ggplot2 and lattice. These are very interesting and powerful packages which you will need to download, install, load into an R environment, and then work with this. Most of the times it is quite useful if you start only with the basic graphics system which is already inbuilt in R, and anytime you start R, graphics system is going to be loaded as well, and you don't really need to do anything special other than just issuing comments. So if you're starting out with R, it is always a good idea to stick with the graphics system first to get a sense of what R can do for you, and then for fine-tuning graphs, or if you want to use more complex graphs, it's always a good idea to use lattice and ggplot2. Having said that, if you use lattice and ggplot2 right from the beginning, that is also quite a good idea, because that way you can very easily and very quickly get up to speed to using R and the different kinds of graphics systems. So let's get started with this. The first things first about using graphing systems in R. You will learn about what is known as high-level functions and low-level functions. What are high-level functions? High-level functions are like looking at the larger, bigger, broader picture of the graph that you're going to play with. Think of it like setting up a canvas, putting a paper on, and then planning the project. What are low-level functions? Low-level functions in case of R graphics is where you now zero down on the graph proper and then start adding lines, points, text, etc. As I said before, the inbuilt graphics system actually allows a lot of high-level functions done, and using the inbuilt graphics system, using the high-level functions, you can get pretty much a large number of things done. Of course, it also allows a few low-level functions, which we will see. However, with grid-based systems, particularly lattice and ggplot2, they will allow complete plots. You don't really need to do too much of low-level functions, as we will see, and as you all see. And these are essentially high-level functions that are already inbuilt within the ggplot2 and lattice. It's rather complex, but very, very useful. So now let's take a look at the different devices and packages that are available in R. Now, if you start looking at the different devices and packages that are available in R, R comes with some graphics packages. And these graphics packages, for instance, the lattice package, which is based on the grid system of graphics, or the maps, which is based on the standard traditional graphics systems of the package. And then you have got beneath that layer a system which is known as graphics systems, which is think of the graphics system like a canvas on which an artist draws and paints a picture. So you are drawing with pixels and you're drawing with data. And so what you're doing is you need a system on which you can lay your data sets and you can lay your data and you can then paint graphics based on the numerical and statistical information that your data has. Of course, at the end of it, you got different kinds of devices that you will be opening at various stages, and these devices will actually direct your outputs into different formats. For example, let's say you want to find out or push from your R program something to, let's say, a PDF document. Now, when you're writing a PDF document, your graph can be a whole PDF page. Or say, for example, you are interested to push your graph from your R program into a PNG document, a portable network graphics document. This is a device. You have to open a device, you have to push your codes from R and your drawings into that particular device, and then you have to close the device. We'll see a few examples of this. A very common graphic device is the JPEG device, the Joint Photographers Compression kind of device, which gives you highly compressed figures that are very useful for publishing in web pages or, for example, in journal articles, etc. So this is why you need certain devices. And then on the top of that, you have got a few things such as graphics device packages. However, in the course of this particular lecture, we are going to talk about only, we cannot cover everything. So we will be focusing on the inbuilt graphics system, which is a graphics system that you can see over here. We'll talk about the grid system, which is present here, and we'll talk about the lattice, which is built on the grid system. And note that maps, the lattice, they're all coming over into the graphics and the grid systems, right? And all of these, and both graphics and grid systems are again map onto the different graphic devices that are open from time to time. So let's take a look at what are the different kinds of plots that are available in R. And I'm only going to show you a few very popular and interesting graphic applications. Note that there are quite a few that are available. So this is the one. Now this set of graphs that you're seeing here on the screen are basically based on the inbuilt traditional graphics system. And if we move from clockwise going down, we see the first one is a histogram of a particular variable. And this histogram of y, for example, is also showing that there is a superimposition of a density plot that is on that particular bar plot that you can see, this on the histogram that you get to see. So you can see that you can actually draw two different things onto a same graphing canvas. So the high level function was the histogram of y, and then the low level function or the low level plot was the kernel density line that you can see over there. Another one, as you can see moving down, you can see that there are a series of box plots that are printed on this page. And in those box plots, you can see that there are legends that are given, for example, ascorbic acid and orange juice, the vitamin C dose, and etc. Those ones are, those could be produced within they're essentially high function or high level plotting functions, but you can see that there is a box plot that were given. And you can see that it's quite possible that, and these were, for example, R automatically decides how to put the box plots and how to shape it up. Because R plots are extremely powerful suites of plotting functions that are very, very popular. So if you are into data visualization, this is a great way to look up things. You can see pie charts, you can see 3D plots, you can see bar plots, and then finally we see a few line plots that are there. So and this is just a selection of the different kinds of plots that you get to see in R. R's suite of plots is much, much more broad, which you will learn in course of time. Here's another set of plots which are based on the grid systems, which are known as the trellis plots. And you can see that here the distinctive feature is this, that you can have multiple panels and you can split data based on the particular data that you have. Now, one of the questions is which systems to use. In general, it is always a good idea to stick to any one system. So if you start with a grid system, which is a traditional grid system, then it is better to stick to the traditional grid-based systems. Or if you're starting out with a graphics system, which is the inbuilt traditional graphics system, then stick to the traditional graphics system. It's usually not a good idea to mix up with the graphics and the grid systems. If you're planning to use grid system, then it's a good idea to use and install and load the Lattice and the ggplot2 packages, because these are highly feature-rich programs. On the other hand, the traditional graphics-based system is very convenient and it starts at runtime. You do not really have to install anything special or extra if you have already got an R installation in here. And therefore, the general advice is this, that if you're starting out and you only need some basic plots, then just use the graphics system, the inbuilt graphics systems, and it will be well put. But if you need complex visualizations, it's a good idea to use Lattice and ggplot2. Enough about the theory of building canvases in R. Let's take a look at how do I actually start plotting graphs in R. Now, one of the things which is very important in terms of start plotting graphs in R is this, that all basic plotting functions in R are generic. In other words, if you just type plot and then give R within that plot function the parameters, then you know that R is going to give you a correct plot. And therefore, as I said, that if you've got an inbuilt graphic system, that's all you need. All you have to do is just give an instruction of plot, give the variable names, and R will return you a good plot. On the other hand, if you have to use Lattice or ggplot2, which are like grid-based systems, then you need to know a few other things. Well, first of all, you need to actually call the library in. So you have to actually have the packages called into your R workspace. So you'll have to say something like library Lattice, library ggplot2. And if those libraries are not loading, then you know that these packages need to be installed. So you have to first install them into your R installation, and then you have to call them using the loading functions. And generally, you will include the parameters and descriptions and options, etc., within parentheses within the plot functions. But the other important thing, if you're going to work with grid-based systems such as Lattice and ggplot2, is this, that all graphs are actually saved as objects. In other words, if you issue a command in the traditional graphics system, you will see that a graph is built in an appropriate output. But if you use either Lattice or ggplot2, and if you just issue a command, you may see that nothing comes out into the output. But do not be flustered, because what has happened is this, that particular function or that particular command is actually meant to be saved as an object. So type the name of an object and then type the command using ggplot2 or Lattice, and then print that particular object using the print command to see how the graph looks like. Some of these examples are worked out in your RNW file or in your PDF file, so go and take a look at this and do some practices. This is just a theoretical exposition of how it works. All right, so that's why I said that if you want to take a look at the graphs, print object. Now, let's see some of the very basic high-level plotting commands that you can use. Well, if you want to use some basic high-level plotting commands, then you use plot within parentheses for scatter plots. How does that work? Let's say you want to do a scatter plot of two variables, and both these variables are continuously distributed variables. So variables which are like scaled variables or variables or ratio variables, let's call those variables x and y. So what all you need to do is just put plot x, plot x, comma y, and R will return a um, using the grid basic traditional graphic systems, R will produce a scatter plot. That's just as simple as that. So if you go and take a look at the RNW command, now you will see that R has actually produced a scatter plot of the two variables. On the other hand, if you put plot and then put a categorical variable, R will try to guess whether that's a categorical variable and then will put out a bar plot. You can also actually specify what kind of plot you want to R by putting things like bar plot and then typing the name of the categorical variable in it. And then you can add the different options for the bar plot. Usually type help function or type help for bar plot and you can get that. A slightly different thing happens when you use box plot, because in this particular situation, if you pair up a continuous with a categorical variable, then R will generate a box plot. You don't have to do anything else. You just type plot, then type the continuous and the categorical variable together, and R will guess and produce a box plot. But you can also specify separate box plots for the categorical variables, and R will do that for you. Now, if you want to generate on the top of, say, histograms density plots, then you'll have to invoke some low-level functions. And these low-level functions are usually done by using lines, and then you use density, for example, for the density functions, etc. Okay, and so on. So what kind of things go on in high-level plotting commands? You have start with plot, then open a parenthesis, then type the variable or the data, and then you write your options here. For example, if you wanted to use colors, type the name of the color. Just in most circumstances, if you type the name of the color, that's enough. For example, red or blue or black, depending on the canvas that you want to use. And then if you want to fine tune the lines, you say, the type of the line, like dashed or bold, broken, etc. If you want to use the point character, then there are codes that are available for you to type the particular type of line. Let's see some of these things. For limits on x and y, you can see that you can put for axis, you can put how much where the axis should begin, where the axis is going to end. You can put those limits. You can also label your axis. You can use xlab and ylab, that kind of stuff. You can title it using text, and you can subtitle it using whatever text that you want to use to subtitle it. And this is going to work for both traditional graphic system as well as for lattice and ggplot2 kind of things. The second thing, of course, is this, that after you have conducted a high-level functioning, after you've done some high-level plotting commands that you've given, you'd like to annotate the plot. So, for example, for adding additional lines to your plots, use what is known as a lines function. Okay, and then within the lines command or within the lines function, you use some of the other comments that you want to use for what those lines are going to be. For example, if you wanted to put a density plot next to your histogram, then you're going to put density function within the lines function, and that's quite possible. If you want to use add data symbols, use the function points. If you want to use annotate and identify particular points, type identify. But quite often, we would like to see multiple plots in the same page. And when you do that, you use what is known as par or parameter function. And in this particular case, what you do is this, that using the par function, you actually specify the rows and columns. So if you wanted to put like two plots side by side, which means there are 2 columns and 1 row, you would say that, look, I'm going to put like C, which is, catenate, 1 row and 2 columns. So rows come first and columns come second. And then you would like them to fill it up row-wise. So you'll say MF row, which basically tells you that you would like to have the row filled row-wise. Okay. The other thing which is very important with respect to R is how you take out a graph. In other words, you are starting within an R canvas, but you are going to put it out in a particular device, say for the PDF or PS or JPEG. And I'm going to show you, there are basically 3 rules for this. First, you open a device, and I'll say PNG, or if a PDF, then you say this file.pdf. Then you push all your outputs, so everything goes into that particular device, and then you close the device. Never forget to close up the device, otherwise it's just going to eat up on your memories. And this slide, for example, shows you all the different graphical formats that you can get to see in R. If you are not exactly sure as to what these are, for example, you can use a file device like PostScripts or PDF or Xfig or Bitmap or PNG or JPEG. These are the ones that are most commonly used in most circumstances. So that's how it's going to work. And of course, you can see that there are quite a few different kinds of windows, etc. But most of the times, you will be working within file devices, and that should be sufficient for most of us to get some things done and some work done in this. So this is about using the traditional graphic system and using R with the traditional graphic system. Now let's take a look at the grid system and see why it's important. Now, the grid system is very important because the grid system is essential for complex and perhaps more feature-rich graphing functions. It's very feature-rich in the sense that it lets you customize a lot. People have actually written packages based on the grid systems. However, the only other inconvenience, if you will, is this, that the grid system needs to be installed and called. In other words, you have to install a particular grid system, and then you have to load the grid system when you want to use this. How do you do this? You do use install packages, for example, for ggplot2, or install packages for lattice, and then you call that within an R environment by using the library ggplot2 or library lattice, and they will save all the graphs as objects and let you update the objects. And that's the other important thing. That is, if you use these as objects, then these objects, you can actually update those objects using different functions. If you get into your RNW file now, or in your PDF files now that is accompanying this particular lecture, then you can see that in the particular relevant section how I have updated a particular object that I created using the grid system in Lattice, and you can see how that updated object will now change if you start putting together your graphs. So let's spend a few minutes looking at the lattice plots to see what do we do with lattice plots. Well, the lattice plot is a very powerful system of graphing. It was designed by an Indian statistician, Dipan Sharkar. And the way you do this is that you install lattice by typing install.packages, then within quote marks lattice, and it will install it for you. Then you call it into your R system by using library lattice. Now, here are a couple of things that you need to know, really, because lattice system works using a formula. So you say X, and then there's a tilde sign, which you will find on the top of your tab column in most keyboards. And then you use the tilde sign to indicate whether you want to use one variable or you want to use 2 variables. If you want to use one variable, then type tilde and the name of that particular variable. If you want to use 2 variables, then place those variables side by side. Usually, if it's like an X and Y, then the Y or the Y ordinate goes first, and then the X, etc. Then you have to specify that you want to use a data set, because you have to use a data frame in order to use this for lattice. So you say you use a data set, you call the data set into R, and then you say that X tilde Y, and then put a comma and say that, look, this is a data set on which I want to work with this. Now, one of the most important and a very interesting feature of of lattice plots. And you will see when you start working with the lattice plots using the RNW files and the PDF files, interactively producing those plots, you will see that it'll let you actually set conditional variables so that you can condition those plots based on some other third variables. It's a very, very powerful feature. Okay? And usually all the other options and functions, etc., that you get to see are very similar to traditional graphics systems. So you can put additional parameters, for example, like titles, headers, the limits of the numbers and values for the x-axis, for the y-axis. You can label the x-axis, you can label the y-axis, etc., etc. And just take a look at it, the different kinds of how you can map between the traditional and the lattice plots. This is taken from an excellent textbook by Paul Murrell, which is known as R Graphics. If you have the time, you must read that book. It's a beautiful book, and it explains in great details how you can do really good graphics within R. So this is how it works. For example, in case of if you wanted to put together a bar chart, then what you will do is this. In case of lattice, you are going to type something like bar chart, of course. Then you'll say tilde and x, and then specify the data, and you can do that. Whereas in case of traditional graphics system, you'll say something like bar plot, then put the name of the variable or data, and then a dollar sign, and then the name of the variable, and it's going to do it for you, and so on and so forth. So you can use box plots. It's called BW plot. In case of traditional system, it's known as box plot, just as such. Now, obviously, you understand that in the traditional systems, as we showed you, that you don't really have a way to plot kernel density plots. You don't. So what you do is this, that you specify the density function and add lines to it, right? Whereas in case of lattice function, you can see that you can do this. Similarly, for example, with a three-dimensional scatter plot, you don't really have something like that in the traditional system. So that's why I said that when you want to use traditional system, use a traditional system if you are not going to be using some of the advanced features. Otherwise, if you are interested to use advanced features, then it's always a good idea to stick to lattice functions. If you are starting out, if you're using basic functions, you will be mostly using the traditional functions. So, for example, parallel coordinate plots. These are the plots which you cannot really have. You can really you can build them, but it's much better to use the lattice function right away. Okay, so that's one of the ways in which you can do this. For example, if you use XY plot and then give the x and y values, it'll produce a scatter plot in lattice. Whereas in case of traditional, all you need to do is just put plot, and that's about it. Okay. So you can map between these different systems. A good way to do this is to type the specific help files and then go from there. Now let's take a look at what is known as a ggplot. Now the package ggplot was devised by Hadley Wickham, who is a very popular and a very very high-profile contributing member to the R community, Hadley Wickham, and he based it on an excellent text on graphics by Leland Wilkinson, known as Grammar of Graphics. As before, you will need to install and load before using. So if you want to install by typing install packages ggplot2, and you load it. Now, just as you have got plot within parentheses and closing parentheses for the for our R system, you have qplot here to do this work. And then again, you can use the same motif. For example, qplot x comma y, you specify data, and then you have your options. The options are very similar to the options that you get to see in any of the high-level functions that you get to see in the traditional graphics. And to repeat once more, exactly as in lattice, this is a grid-based systems. Everything's saved, and so you can use a print object to see your graphs. Otherwise, you may not see anything, any output at all. So don't be disappointed. These are all saved in the form of an object, and you print an object to see them. Remember that because it is a grid-based system, it's very useful for conditional plotting. It's very, very useful for breaking up the plot depending on the levels of the other variables. It's actually very useful for a number of different things that you can do with this. I can't do an extensive number of graphic runs for now, but for the moment, take a look at this and what you get to see. What I've done is I have installed the datasets sort of data from the R graphics package. It's already in there, so we don't really need to do anything more than that. And then in the next one, I'm going to just plot a particular package. It's called the pressure dataset, and it's got a couple of variables. So what I'm going to do is I'm going to run this particular chunk and see what R does for you. Okay. So I go to the chunks and then I click on the run current chunk, and you can see that R has produced a neat scatter plot. And R sort of knows what are the variables in this particular data set, and it just does it automatically. Very simple. It just put plot and it just does it work. Now you can also use open a device and then push a particular kind of figure or an image into that particular device and then turn the device off, but we are not going to do that. It's a pretty trivial example. The second thing that I'm going to do is I'm going to create a random series of 20 points, and I'm going to display how these 20 points are distributed, right, along their index values. And I'm going to produce 4 different kinds of graphs, and these graphs are like arranged plot Y type point character, line graphs, both points and lines, as well as a histogram like vertical lines. So very simple. I'm going to put a random number, a random sequence of 20 points, and I'm going to put those graphs. Again, very simple. There is a chunk. I'm going to the chunk, and I'm going to run the current chunk and see what it does. The first one, the last one, of course, here is the histogram like vertical lines. And then I move up a little bit, and it shows me both, so both point as well as lines. And then I go over there, and it can show me the line plots that it produces. And then finally, it can gives me the point plots. So using this sort of commands, you can do quite a fair bit of work using only graphics package. Nothing more is required. And as we told you before, it can, if you just put plot, it'll sense what variables there are, and it's going to put a scatter plot. But you can also actually specify what variables you want, but don't specify whether you want a scatter plot or will still produce a scatter plot. Okay? So there are 3 different ways to produce the same plot. The other thing that R does, and it's very nifty, is this, that you can run a linear model, and then what you want to do is you plot the linear model. By plotting, what I mean is this, that you give or you pass the argument of an object of a linear model, and then ask R, can you please plot this model, and see what R does for you, right? So we get to this particular chunk, we go to the chunk, we run this current chunk and see what it does for R. R will ask you or prompt you to see specific plots, right? It's a very good tool for learning and teaching. So the first thing that R does is it produces a residuals versus fitted one. The second one it does is it produces a normal QQ plot. And then there are a couple of other plots that are quite important for diagnostics of linear models. You can see this right here, right? This one and this one. Next, what we're going to do with R is we can ask R to produce a box plot, and see, this time when you produce a box plot, you're going to take a decrease as a continuous variable, treatment as a categorical variable, and it's going to produce the stacked boxes. So we'll go to chunks, we'll ask run to produce a current chunk, and it produces those stacked boxes. You can add parameters to this, and we have already covered that in our lecture, so I'll leave you to play with this a little bit. Now I'm going to show you a couple of other things which are quite useful. The first one of them is how we use lattice, and lattice is actually quite interesting. And in order to do this, we have to require lattice, so that is load the lattice library over here. That's exactly what we're going to do here. So and we have already installed the lattice package, so I'm not going to do that again. And so what I'm going to do is I'm going to load the lattice packages and lattice extra packages into my workspace. So I go to chunks, I run the current chunk, and it loads those packages in there. And then within the lattice package, they've got a data set that has got earthquake data for, 1,000 earthquake data for the country of Fiji. And so what I'm going to do is I'm going to produce a scatter plot of the latitude and longitude of the Fijian earthquake data. So the data are data quakes, and the latitude and longitudes are given here. And I'm going to produce an XY plot, and then I'm going to store it in a lat-long object. And so you can see that how it's going to do that, but this time it's produced an ugly plot with only plot point characters. So, but nevertheless, let's go and see what it does. And this is what it's going to do. It's going to do nothing. Why? Because it has stored everything in the form of an object called lat long. So what, to produce it, we just reference it and we say R produce a lat long plot that I asked you to do, store in an object. And then it does it. Well, it's not very pretty. So what we need to do is going to update this particular object, and then what we're going to do is we're going to run the updated object. See, I have updated this particular object, and this time I asked them, look, give me a heading, a title, and produce X-plots. So it's going to do that again. So I'll go over here and then just run the current chunk, and like, whoa, presto, it's going to come up with this X cross-hatched marks, and we could probably zoom it a little bit, and you can see that they've got the cross marks in here. So the next thing that we're going to do is I'm going to show you that you can nest certain variables within this. And when I say that you can nest some variables within this is that let's create another variable called depth level. So we indicate the depths at which those earthquakes occurred, and nest them and see stratify this particular scatter plot along those lines and see what it does for us, right? So we go there, we run the chunk, and you will see that there will be 3 graphs that will be put out. Okay, so now we get to see that there are 3 graphs that are being put out. 1, 2, and 3 is coming up, and you can see that they have put out, according to the depth level, the lat and long scatter plot. We can go a little farther than this, and we can actually then do 2 levels. So we'll say depth level, and then we create a binary variable for the magnitude of those earthquakes. These may seem like trivial exercises, but this gives you a sense of what you can do with R. And so this time it's going to come up with 6 separate plots. And see, we don't have to do anything much. The lattice configures itself. So we go to chunks and run the current chunk, and you can see 6 plots that are going to come up, right? So 1, 2, 3, come up, 4, and 2 more are going to come up, 5 and 6. So in these 6 plots, you can see that they have been binarized magnitude and the depth levels, and they're all combined, and you can get nested levels of plots. So you can actually keep on creating as many nested levels as you want. Lastly, I'm going to show you how ggplot2 works. Once more, I've already installed the package, so I'm going to call the ggplot package, and then I'm going to put out a plot which is going to store a plot of the value of diamonds in prices. The data are diamonds, and a carat is a caratage of those diamonds, and see that the relationship between the two quite visually. Again, you can do a lot of work with ggplot2. I'm only going to touch the very basic surface. We're going to plot everything, put everything into an object, and I'm going to plot them, right? So the way to do the plot is to print my plot. So I'm going to put this over here and run this particular chunk and see what it does for you. It takes a while because it's a complicated and big program. So it's going to come up with its own graph, and you can see that the carat is put on the x-axis, the price on the y-axis, and you can see how the scatter plots are working. So you can do a fair bit of work with R. You can start with a very simple graphics package, but you can also use lattice and ggplot to get your work done. I hope that gave you a flavor of what can be done with R. So now we have had a fair bit of a kind of a trip, if you will, of the different kinds of graphing functions within R. So let's take a look at the points that we have learned here. What did we learn? We learned that in R, if you want to produce a graph, You start with an empty canvas, and then you've got a couple of options. One of the options is the simple graphics system, which is a traditional graphics system. It's a very, very simple graphics system. It is inbuilt. It will load when R loads, so you don't really have to do anything else. So just type plot, and R will try to think and produce a plot out of this. On the other hand, you can use what is known as a grid system. And we identified that there were a couple of very important and very interesting packages which will enable you to take advantage of the grid system. One of them is Lattice, the other is ggplot2, but they will have to be installed and then called during the operations of the runtime of R. We learned a little bit about the high level and low level plotting. High level plotting is like taking a very high, like almost like a 10,000 feet view on the canvas, and then you're plotting something. Low level plotting is where you will actually then zero down on your canvas and then start putting lines and points, identify characters, etc. And then we saw that you can make some really, really good and very interesting graphing patterns by using the grid-based systems, because grid-based systems are quite powerful and quite useful. Two very interesting packages that you can use for graphing in R, which are like complete systems, are Lattice and ggplot2, and so that will be that you can use quite a lot. Now, to conclude this particular section, as I said, that you need to really a lot of practice for this kind of work. And although this is a theoretical lecture, I just introduced you to the basic idea of the canvas and how you can use the graphs and plotting. I have also actually included for your practice and for your review an SV file, which is titled as RNW file. So go through that RNW file, run through the examples, and then highlight and run them and see how the plots are coming up, and then modify those codes and see how these codes are. It's always at the end of the day, an exercise where you should do and you should learn for yourself. So follow along the code book and practice, practice, practice.
So we had a tour of the different features of R for doing graphics. We learned how to use R's graphics functions for using our own inbuilt graphics device and engines to create moderate and good-looking graphs. But we've also taken a tour of the Lattice package. We learned that we can install a Lattice package to create good graphs. We also learned a little bit usage of the ggplot2 that you can install, and then you can use it for good purpose. And I hope that this particular and this short introduction to the graphics systems in R has given you enough of an introduction so that you can now start running your own graphics and own graphs using a number of different ways. And so this completes the second part of the introduction to R in how to use graphs. In the next, we're going to learn about using R for learning about objects and functions, which will complete the 3 modules in R for getting an introduction, and then we'll start using R for some real productive work using biostatistical data analysis. So thank you for paying attention and keep learning. Thanks.